Now that we have our main variables, locals, and data resources, it's time to populate our submodules and then populate the main.tf with our code. So we'll start with the security group. If you look keenly, you'll notice we don't have variables.tf. So we'll start by creating that file. Once we have our variables.tf, we'll just pass in a few variables that this module will be using. So the module will be expecting a name, which will be the project name that will be appended to its resources. The module will expect then project name, which will use this variable name. The module will also expect VPC ID, which will also be a string like the previous one. Module will also expect a third variable, which will be the module's unique ID. You can pass in a unique ID to identify between the different instances. After that, we need 3 variables. The first one will be the ingress rules. So this will be a list of objects because ingress rules can be many or one. Just enter the name, ingress rules. The type of these rules or this variable will be a list of custom maps. So we'll just use the object data type, and within this object we'll have the following fields: a list of string, the CIDR blocks, and then we'll have the description. We'll also have the from port number, the IPv6 blocks. We'll also have the prefix IDs, the protocol, which will be a string. Then we'll have a list of string that is for security groups. Have the to port, which will be a number. And lastly, we'll have the self variable or self object key that will be a boolean. So when you look at this, these are the typical arguments to an ingress rule or an egress rule. So we are just specifying the data types. And then here we'll just give this a short description. We'll call it ingress rules for the security group. So we'll give it a description as follows: ingress rules for the security group. Then we do not expect a default value so that this argument can be required. We can just copy this block and add it at the bottom here. Then we need to change this to read egress rules. For the egress rules, they'll use the same structure, and then the description, just make sure you update it to read egress rules. Lastly, we need a map of tags. So this variable name will be called tags, and this is basically the resource tags. Once you have this, this value can have a default of an empty map so that it can be made optional when the module is being initialized. So that's it for the variables. We need also to update the versions. For the versions, we'll only be using the AWS provider, this one right here. Just close all the files first, then open the versions.tf file in the security group. We'll have to initialize the Terraform block, and then we'll enter the required providers. Just enter the AWS provider the way it's documented on Terraform documentation. Copy this. For this tutorial, we are using this version. You can use any version you prefer as long as it works for you. This is all you need for this module. And versions.tf. You can also add the required Terraform version just in case you want to restrict the minimum Terraform version. So for all our modules that will be using the AWS provider, this will be the structure that they'll be using. So let's move on to the next file. So we'll create our main resource, the security group itself. We'll only have one resource for this module, and its name will be AWS security group. Its name will be main, and then it will have the following arguments. The name will be created from the following variables: the var.name with var.unique ID. So these two combinations of the project name and the unique ID of the module will form the security group name. Then we have the VPC ID. This will be supplied from this variable. Then we have the ingress block supplied dynamically using the dynamic block. And then for the dynamic block, it will be looping using for each on this list for ingress rules. This is how you loop within the dynamic block. Then in the content, we'll just be passing this object and then reading it from the for each loop. So let me copy this block. And then under content, let's paste this block here. And then we have to substitute the values using the for each value. Under our dynamic block, we have to read the values using the dynamic block name. In this case, it's ingress. And then we'll just do dot value. And since the variables are using the same names as the keys we are using here, value will be value.CIDR block, because now value gives us the single object within this list. We'll do the same downwards. So just copy ingress.value, and then at the end, we add this. So I'll just repeat the same for the rest of these keys. We've populated the ingress rules. We need to populate the egress rules, which can also be a list of several rules. Under egress rules, we can populate the same way. So we start with the for each that will be reading our list from the var.egress rules. So just make sure you are using the correct variables. So for ingress block, we are using ingress rule variable, and for egress block, we are using the egress rule variable. Then we need to add the content block, and in the content block, we'll just copy this, and then make sure you change ingress to read egress, because we are now in the egress block. Lastly, we need to pass in the tags using var.tags. We need to merge the tags using this option here. The merge function combines two maps within Terraform, so we'll take advantage of that. We'll create a new map here of name, and our map will have the value of the name of this resource. So just copy the resource name at the top here, the one that we created, and paste it down here. Now we have two maps, the map that we created and the map that comes from the module. Now that we have main ready, we'll create our outputs. So under outputs, we'll have several things. We'll have the security group ID, whose value will be the resource name .main.id. And then we'll also have another output, the security group name, which will use the output name, whose value will be the resource name .main.name. With those two outputs, we are ready to go. For the security group module, it's a simple module with just a single resource. So it did not use the locals and also the data.tf. Let's move on to the next module, which is the Fargate profile. For the Fargate profile, we'll start with the versions. We'll just close other files. This is the Fargate profile, which will be creating our Fargate resources that will be used by our pods. So under versions, we need the same versions the way we set under security group. You can just copy it from here, the way we typed this, and replace it here. Next, we'll add the variables.tf file, which is required to pass in our input variables. And then under the variables.tf file, we'll just add the following. We'll have a common block for common variables. Because there are many, I have to categorize them so that they make sense. So we'll have var name, which will be our project name. And then we'll have var for the unique ID, which will use the name unique ID. So this will be the modules. Then under the common variables, we'll have just tags. These are the variables that will be shared. And for tags, we just use a simple description. So make sure you use the correct variable type. Tags will be a map. Unique ID is a string, and the name is a string. So for tags, we'll pass in an empty default map, and the description will just use resource tags because it explains itself. After the common variables, we need to specify the identity access management variables. That's the IAM variables. Under IAM, we have 4 variables. We'll start with the create IAM role variable, which will be a Boolean. Make sure you change string to Boolean. And under description, use any description you want as long as it makes sense to you. By default, we want to always create the IAM role even if the user has not specified this variable. So that's why we are putting the default of true for this setup. Next, we need the pod execution assume role ARN, and it will be a string with this description. The default for this one will be null or can be null. So we are setting it to null. Then we'll have a third variable which will be a Boolean 2 that indicates whether to attach the CNI policy. And lastly, we have IAM additional policies that should be attached to the Fargate profile IAM role. This one will come in as a map of strings that we can iterate through. Additional policies for the Fargate IAM role. And by default, it will be an empty object. So anytime you see us applying the default, it means that the user can ignore that value and this default will come into effect. So any default with null, Terraform resource will ignore that, but any default with a value like this will be read by Terraform. So we've created the IAM variables. We need to create the profile variables. Under the Fargate profile, we'll need to input the cluster name, which is a string. And this will be the EKS cluster name. It will be a required variable, hence we are not passing in the default. The next variable will be the profile name. This is the name assigned to this Fargate profile. We'll need subnet IDs. Each profile needs at least 2 subnet IDs in 2 different availability zones. That's the minimum. And we cannot use subnets within the same availability zones. Then here we'll pass a list of strings. And the description will be subnets for this profile. And then we'll need the selectors variable. This will be a list of an object type. This is more of a custom type. So we'll just enter this. And for the object, this is how you initialize a list of objects. An object is just a custom map that can hold different data types. And this object will have the namespace, which will be a plain string. And then we'll have labels, which will be a map of strings. And then for the description, we just say Fargate Profile, selectors, and namespace. We'll supply a default value just in case the user doesn't pass in the required settings. So under the default, we'll just be creating a profile that will be selecting the app's namespace. Under labels, we'll just have name, and then the next selector within this, we can just copy the first selector. This will be a wildcard selector. And then lastly, we'll specify timeouts for Terraform lifecycle. Just name it timeouts. So we'll have 2 of them, which will be a map of objects. Make sure you use the correct data type. And then this will be Terraform lifecycle timeouts for the Fargate profile resources. The default will have create as null. You don't have to quote the key unless it has special characters. So you can leave it plain or quoted. Then for the value will be null. Then we'll have another one for delete. So by default, you are not passing in any values. Those are the variables for the Fargate profile. Now we need to populate the other resources. So before we go to main.tf, we'll create the local variables for this module. We'll initialize the locals block. And under the locals block, we'll have the IAM role policy, and we'll just name it prefix. This one will be read from the data resource as follows: AWS partition.current. Then we'll just take the partition output from that module. And at the end here, we are adding another string that reads IAM AWS policy. The next variable will be the CNI policy ARN, which will also be a string created from the following. We'll be using the above role ARN. So we have local.iam role policy prefix. And at the end of it, we'll be adding Amazon_CNI_policy. Those are the main local variables that we'll be using. Now let's create this data resource. Just open the data.tf and Fargate profile and create the resource here. We'll name it current partition. That's the name of the resource. Don't have any arguments. Next, we'll finish by populating our main.tf that contains the meat of the bone. We'll start by creating the IAM role, which will be put in its own section like this. And then for our IAM role, it will just be the resource, AWS IAM role. You can use any name you want, so long as you make sure when you are referencing this resource, you use the name that you used for your case. For me, I'm used to using main. Now for this resource, we'll be creating it conditionally based on this Boolean variable. So create IAM role. So let's just copy the name, and then under main.tf, just do var.create IAM role. If it's true, we'll be creating the resource. If not, we won't be creating the resource. The next will be the name of the role. It will be derived from the project name, followed by the unique ID of the module. Lastly, we'll append a string called assume role. And a description, you can add any description that makes sense to you. But for our case, we'll be using a description of the following: Fargate profile assumed role. We also need the assume role policy. It will be a data resource. Let's go create it and then come and add it here. So open the data.tf. In the same folder, the Fargate profile subfolder. And here we need to create the data resource. It will be AWS IAM policy document. The name will be the assume role policy. We are just using this to indicate what this policy document is all about. Then for the count, we are going to create it based on the same condition as the one here. So just copy this conditional and add it here. If this variable is true, it creates the resource. If not, it doesn't create the resource. Then we'll just pass in the statement, which will have effect of allow. It will be an array, and it will be sts assume role. And then for the principals, it will be an object. And then the type key will hold service. The principal will be of type service. And the identifier of this service will be the Fargate Profile endpoint. So it will be EKS Fargate pods.amazon.aws.com. So now we've defined our data resource. For the assume role policy, we'll just copy the name and then go back to our main and then add it like this. So data.iam policy document.assume role policy.json to get the JSON format of the policy. Then we'll pass in force detach policies. Here we'll hard code the value as true. For your case, you can pass this in as a variable. And lastly, we have our tags. So for the tags, we'll be using the merge function from Terraform, and we'll be merging a new map that we are creating on the go here. So this map will be taking the name of the role up here, and then it will be merged together with the resource tags. Next, we have to create the IAM policy attachment resource, and this one will be named main. It will be using a for each loop with a for loop within it. The for each will be taking an object, and then for this map, we'll be having a for loop within it. So basically what is happening is that the for each will expect to get a value here that it can map through, but now the for loop within this value will transform the input to a format that for each can use to populate the resource inputs. So for our for loop, we're just looping through this set. So we are using the toSet function to convert a list into a set. Our list will contain the following. So we have to copy the managed policy ARN. It's named AWS EKS Fargate Pod Execution Role Policy. The difference between managed and non-managed role policies. Managed policies are provided by AWS. You don't need to create them. And then from the ones that you create, those ones you manage yourself. The second one will be a policy that will be formed conditionally. We'll be checking a variable, and we'll be checking if the user specified to attach a CNI policy. So the default value for this should be false. And then here, we'll just use that variable var.iam role attach CNI policy. If it's true, then we'll pass in the local dot. So let's go to the locals.tf and confirm. The name is CNI policy ARN. We can just pass in the name like this. Remember, all these files are in the Fargate Profile submodule, so do not get confused between the files. Otherwise, we pass in null. Now we have to be careful here because there is a possibility that we'll get a null entry for the ARN policies. And if you pass in a null for the ARN, the resource will throw an error. So to get rid of that null, we can add another function that will compact the list by removing the null. The Terraform function is called compact. And then just make sure you put an opening parenthesis after the function before the opening square brackets, and add another one after the closing square brackets. And then at the end, the for loop will return, for each key it will return a value if var.createIAM role is true and the value v is not null. Then this marks the end of the for each loop. So we just need to pass in the other keys. So we will just be passing in two keys. So for the policy ARN, it will be read from the for each loop. It will be using the each.value. And then for the role, we'll be using our role, the one we created at the top here. So it will be AWS IAM role.main.name. Lastly, we need to attach some optional policies in case the user has additional requirements. Just create the AWS IAM role policy attachment. For the name, we'll use additional. This policy will be created using a conditional. So we do for each, and then instead of supplying a map directly, we just use the for loop to loop through the additional policies. For key value in var.iam role additional policies variable. So for every key value pair in this variable, on each key we return the value under the condition var.createIAM role is equals to true. So it's not necessary for you to add the equality sign, because if this value is a boolean, automatically it will be read as true even with or without this. So you can remove that, or some people like to be explicit, so you can add that to just be sure. Now the for will result to key value objects for the for each. And then we can just do the following. Policy ARN will be each.value. And then for the role, it will be AWS IAM role. main. Since it's created conditionally by using count, we have to use an index of 0 because it's only one resource, an index of 0 to access it, and then we just do .name. The same here, make sure you use an index of 0 to access this role because it's created with count. We are done with the roles. We need to create the profile itself. So the Fargate profile, and here we just initialize the resource, AWS EKS Fargate profile. It will be main, and then it will be named main like that. And then the cluster name will come from the variable var.clustername. Fargate profile name will be var.profile name. Code execution ARN will be var.code execution assume role ARN. The subnet IDs will be var.subnet IDs. Remember, we defined these variables in the variables.tf file under this module. And then we can add selectors using the dynamic block. These are the selectors for the Fargate profile. And then for the dynamic block, we expect a for each. And the for each expects a set. A set is a form of a list of values. And then here we just pass var.selectors. Then for the content, we need the namespace. And for the namespace, we can use the dynamic key.value.namespace. And then for the labels, we'll use a lookup function that looks for a key within an object. So we'll take the dynamic selector.value, which gives us a specific object within the set. Within this object, we are looking for the key labels. And if this key doesn't exist, we are passing in the default value for this key as an empty object. Lastly, we add the timeouts for Terraform. For the timeouts, we'll just improvise a bit. We can use for each, and we can just do var.timeouts. Remember, this is a single object, so we have to put it in a list for it to be a valid data type that is accepted by for each. Then under content, we are adding create, and for create, and pass it in as timeouts.value. We can even be creative by just using the lookup function. So under the second one, the delete, we can use the lookup function for the object here, and the key will be delete, and the default will be null. So we can do the same for the one above here. Let's just comment that out. We can use lookup for the object itself, and then we are looking for the create key, and then for the default, if it's not there, pass null. Lastly, we need to pass in the tags. You might decide to use the different namings here to concatenate the new name tag with the incoming tags. But for this case, we just pass in the default tags that are passed to the module. That's the end of the Fargate profile. We need to move on and create the Fargate cluster.